The basic idea for the test satellite, the Transiting Exoplanet Survey Satellite, came about in the period from around 2006 to 2008. And at that time, there were only a handful of exoplanets that were known, and we thought in our group about how would you go about building an entire survey of the whole sky and find all the ones that are relatively close by, because the studies that had been done at that time, going back to the mid-1990s, had found a handful of what are called hot Jupiters. These are very large planets, Jupiter size, that were orbiting very close to their host star. And that discovery was the subject of a Nobel Prize later on as the first planets being discovered. And so one of the things that NASA had done at that point was they had provided support for something called the Kepler satellite. And the Kepler satellite would actually stare at one small part of the sky for 3 or 4 years and make a census for that small portion of the sky. So the portion of the sky that they would look at would be about 1% of the sky. Yeah, that's about right. And that was the plan that was made. But and that satellite was supposed to launch in around 2010 or 2011 at that point. So the idea that we had in our group is we had had experience building very wide field cameras for this small satellite called HEDI 2 that we had developed in the mid-1990s. And the basic idea there was we had, in order to determine what the origin of gamma ray bursts were, and these were later turned out, as I mentioned before, that they were coalescing neutron star systems, it was necessary to look basically at the whole sky. Well, the whole sky is about 40,000 square degrees. And so the challenge was, how do you do that? How do you manage to look at a big piece of sky? Because for the goals that we had for that small satellite, which weighed only about 100 kilograms, we had to figure out ways to pack cameras in it that would look at a variety of different wavelengths and then also provide localization so that follow-up of those events could occur. Well, the thing that we knew is that if we could figure out a way to do this for extrasolar planets, and we basically were to look around the entire sky, looking at 40,000 square degrees, that would mean that we could find many thousands of such extrasolar planets, because we had an inkling that there probably were, because from the small number of stars that have been searched, we thought that exoplanets were really quite common. You know, that was our hunch, and we wanted to actually prove that that was the case. The other thing that we also knew was that if these planets were as common as we thought they would be, and we looked around and looked at all of the bright stars in the solar neighborhood, that would mean that in general, the planets that we would be seeing would be closer, because the brightest stars that you see in the night sky are generally closer than the faint stars are, just as you would expect. So anyway, we worked out a method that would allow us to, every time we would look at the sky, we would be able to take images of about 5% of the entire night sky, and then we would basically figure out a way to mosaic the sky in a relatively short time. This was the idea, and initially we were going to use some of the same instrumentation that we had used on this earlier satellite, HEDI 2. But as we got into the project and thought about it for the next 3 or 4 years, We had support from the Cobley Foundation for this work, which we were very appreciative of. And then there were also some other private support that we got from, among other organizations, Google. So they were very interested in the problem, just in general terms, mainly out of just curiosity. But they provided some funding that helped us in this area.